All right, I think we'll get started. So thank you for coming. I see a few faces from my other talk, so I guess I did some good advertising. I'm Trevor Gamblin, and this is Tim Orling. We're here to talk to you today about making use of Labgrid to improve your developer workflow. So a quick agenda for the talk. We're going to go over who we are. We're going to give some background context on how this all came together. I'm going to walk you through what I call the single developer Labgrid loop, which I really hope will encourage you to make use of Labgrid in your day-to-day. Tim's going to talk about automating and scaling up. We're going to go through some challenges we ran into putting this talk together, and then talk about future work. So who we are, I'm Trevor. I'm an embedded Linux engineer at BayLibre. I'm mainly a Yocto Project contributor. I'm a maintainer for a lot of Python recipes and for an automated tool called pytest, which just tells people when their patches are submitted incorrectly. Main interests, automation, Python, kernel dev, all the usual stuff with RISC-V and Rust.
I'm Tim Orling. I'm from Konsulko group, so I'm also a consultant. We both are. I'm on the Open Embedded board. I'm also on the Open Embedded Technical Steering Committee. Been a Yocto Project contributor forever. I'm very interested in automation and in security, over-the-air updates, things like that. And most people know me as the Python guy, but I'm not that limited.
Okay, so jumping right into some background context. So Kevin, who's sitting in the front row, and I had a conversation a while back discussing how to make use of Labgrid to automate a use case he has, in particular, going from a power cycle all the way to booting into your operating system after specifying some custom configuration options for your kernel in U-boot and TFTPing some binaries from a server somewhere. Questions being, how do you configure the U-boot parameters of Labgrid for things like load addresses, and more importantly, how do you scale that up from one board to 50 or 100 or however many you have in your farm? So we're going to cover how we tried to address both of those questions. So the goal of this talk is to show you how to automate interfacing with your hardware. The big thing about doing that is ideally you end up making fewer mistakes in your development process. I know I run into them all the time when I try to do everything manually. We don't want to be concerned with manual access. So the question is, how can we approximate the same workflow for a lot of different use cases? Use Labgrid. How do we minimize the differences of CI setups? Again, use Labgrid. We struggled with it at first. I've got a link here to a training course that Pengutronics offers if you're interested in going into the gritty details. But maybe what we've learned and shared here will be useful to you. The last thing to say on this slide anyway is there's a lot more than we can cover in 30 minutes. We originally had, I think, a grand total of 60-something slides. There's a bunch of them in the appendix still. So make sure to check that out afterwards if you want to look at some more details we couldn't quite fit in. This is a picture of the setup on my desk at home, actually on the shelf above my desk at home, just showing the BeaglePlay, which I used for this talk, connected to Raspberry Pi debug probe, and a couple other cables running in there, the usual suspects. The only thing that's not COTS is the BayLibre Copilot, which is basically a switchable USB power pass-through, at least for my use case, controlled with GPIO. The important thing, again, talking about Labgrid, is the details of this setup can be abstracted away. So I got a table here, again, just showing the hardware I've got and comparing it with what Tim's got. He'll give some details in a second about some of the differences he's got, but the important thing to realize is even though our setups are fairly different, at the end of the day, you can use the exact same command to boot your board from power off or a reboot all the way to a shell and get console access to it with Labgrid.
So the difference for me is that I'm using just a common Silicon Labs USB UART adapter. I'm using a Netgear switch, which is up here, that allows me to control power over PoE, right? Power over Ethernet. I'm also more interested in distros and full images, so I use an SD wire for SD card flashing. But again, we're both using BeaglePlay, and we're both essentially using exactly the same command at the bottom, right? And at this point, all we've done is stop having to remember which SysFS we're looking at and blah, 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 right? It's just get us to a console. That's it. That's the goal.
Okay, so I'm going to do a quick walkthrough now. Again, I've coined the single developer Labgrid loop for this, SDLL. So this is kind of a tutorial, but it's more, the bigger takeaway here is this is really about trying to show you how easy it is to get set up here. An hour or two of defining some YAML files, and you can have a setup that's basically automated, and you can share it with other people, and they don't even have to care about the internals. They can run a couple of commands and get access to, in our example, a BeaglePlay booting a custom kernel. So the first thing you would need to do in order to start making use of Labgrid is you should be defining resources. I've got an example of a YAML configuration for my exporter config at the bottom, just showing a location for my BeaglePlay and how a USB serial port is defined. There's a tool called Labgrid Suggest that the project offers that you can use at least for pluggable devices. It'll tell you when you plug something in how it enumerates and what you might be able to use to match against it with Labgrid. We've got some pointers there, just giving some more details. There are some UDEV things you have to set up, but you can check out the link if you want more info there. This is just another contrast between my setup and Tim's, showing you how the resource configuration is similar, also different. But again, the main takeaway, that command I showed earlier with Labgrid client, even though the two things are different, there's a little bit of extra work between the two YAML files, but at the end of the day, we're using the exact same command to boot.
You can see like we're both using, in fact, the same like aliases for what these things are, right? So we're just generically saying serial port, power, whatever. So that's what the BP serial port is. So you can see that I've got a different driver, and the Silicon Labs doesn't really have a sensible serial number. So I'm using, a full path to, basically sysfs, but you don't have to remember that, right? It's in your config, and then you just keep using it forever. But because I've got the SD wire, that's in here, and also I'm using PDU daemon to control the Netgear switch, and so that's in here as well. But that's all basically abstracted away, right, at this point.
Yeah, so using the resources, once you've got that defined, you can start by doing what's called creating a place. In order to get Labgrid running, you run first what's called the coordinator as just a process for managing your resources and handling access. Then once you've got that running, you can run Labgrid exporter. And by the way, this all assumes that you're running on the same host. There are options to distribute things a little bit, but to keep things simple, I assume that you're using one machine. You can run Labgrid exporter pointing at your exporter YAML config, make resources available to Labgrid. Once you do that, you can create a place. You can add a match just to indicate what what resources should be available to that place, and then you can acquire it, which gives you the unique lock so that no one else can access it while you're making use of it. And there I've just got another example where I'm running Labgrid client resources to see what resources at this point Labgrid sees. And just as a side note, the host name there, my box is called EcoGrid. That's the actual host name showing up when I run that command, not the location that I specified in the previous slide.
And so this exporter YAML, this is to let the coordinator know what your device is putting out there for like everybody else to be able to use, right? So the next thing is a different concept.
Right. So manual interaction, at this point, you can make use of what you've done. So the example I have here is if I want to access the BeaglePlay via serial port and control the power, I offset this to try to illustrate that these are actually two terminals. So the top box is me running console, saying I want the console to the BeaglePlay. The second one is turning the I/O on the Copilot high, and then the final box is just going back to the first the terminal from the first one and showing after a little bit of time the box boots and I've got the login prompt. So just a reminder of our goal, just automating interfacing with the hardware. The manual control is nice, but at this point it's not that much better than just doing everything yourself. There's still a lot we can do. The main benefit at this point, you've already abstracted things away, so you don't have to care as much about how things are actually identified on the system. To go a little further, the next thing you can do is you can specify an environment file for Labgrid client to know how you want each resource to be used. You do that by specifying what are called drivers, and each one of those comes with a lot of those come with different parameters, just saying for delays or like prompts to match against, that sort of thing, depending on what driver you're actually defining. This is an example of what that looks like. This is a simple one. This is just showing me binding some drivers, a serial driver, a GPIO digital output driver, and a digital output power driver to resources. The digital output power driver is actually binding to the GPIO digital output driver so that I can use a more convenient interface to say, we'll see later, Labgrid client power cycle instead of IO high, IO low, because we don't want to really care about the fact that it's a GPIO. The bindings here, the binding fields, those aren't necessary if you've only got one of each type of device in your setup, but we did it anyway just to make it clearer what everything matches against. But where things really start to get interesting is when you look at things like the U-boot driver. And here, I've got it binding to my console. I'm matching an auto boot prompt, just saying U-boot's waiting for you to tell it to break into U-boot, what the interrupt looks like. And then I've got a boot command listed in here called myTFTP, which I'm using to use the existing rootfs that I flashed onto the BeaglePlay eMMC, but TFTP a custom kernel and device tree from my TFTP server, and then I can make use of that with Labgrid client to boot to that state with my board. So there's a reminder about our goal again. In practical terms, we want to be able to reliably transition from power off or do a power cycle and get to the shell, assuming that our kernel is going to boot, the device tree is well formed, all that. The last thing we're going to need to do that is write what's called a strategy. That's basically a custom Python module that has a state machine in it. I've got an example linked. The important things that to consider: you've got a status, which just indicates all the different states your board could possibly be in, and a strategy class that you define. Again, a state machine, and listing all the states, how you get into them, how you transition between them, and potentially any helper functions you might want to do to help with setup ahead of time. And I've just got an example of that where I'm transitioning to the shell. You can see I'm actually telling it to boot into another status, the U-boot, so break into the U-boot shell, and then do the server setup and the TFTP boot, and then wait for the shell to come up. So at this point, we've got a big improvement over when we just had the resources. So from either the Python interpreter or with Labgrid client, there's that familiar command again. I can run a couple of lines or even just one line and go again from nothing to power off into the shell state, assuming the kernel's good. So this is a huge improvement for the lab, right? Again, I'm actually using this in a slightly different context on a project with one of my coworkers right now. He doesn't know anything about Labgrid, but I've given him access to a machine, and all he has to do is start the Labgrid environment and run a command, and he gets reliable access to a board we're using for development. But the question then is what if we want to automate this even further and go into CI? And that's where Tim's going to take over.
Yeah, so up till this point, right, we've had standard kernel developer workflow, right? You're making some changes, you compile it, you want it on target, you want to see what it did, right? That's all we've done so far. But we made it automated so you don't have to remember all the details and type 10 lines of commands on the command line, right? Just one. So next we want to do automation. So at this point, I'm going to use GitLab CI for automation, but in the upper right-hand corner, I've got the hierarchy I'm using in all of my projects. So in my BSP layers, I have this testing folder. Underneath that, I've got the Labgrid folder. That's where my exporter YAML goes, where my client YAML goes, and where my strategy goes. And then underneath that, and then also sibling to that, I've got pytest folder where I've got, any kind of common stuff goes in conf-test-py. And then I've got my individual test files. And I put the numbers in there because that forces it to alphabetically go in exactly that order. So now I can group, different tests in different locations and know what order they're all going to run in. And then there's also a pytest ini. So looking at the test, the user space test, it's a really simple piece of code, and all it's doing is just seeing is bash available and is ls available, right? It's a very, very pedantic test. But what happened already by the time this test ran? I power cycled, a TFTP booted to a custom kernel and custom DTB. I've already logged in. I might have already done some other interaction in U-boot and so on, right? And now I'm in a console type of environment and I'm running this test. So this basically tells me, hey, user space is good, right? Other tests are pretty easy to write, and I've got examples in my repo. And then the last thing is, with the pytest INI, it's mostly used for like formatting and stuff like that. But the key thing as you're scaling out, right, is the test paths. So if you have tests in multiple repos, you can start setting up a hierarchy and having all those different paths using other common test cases and have all of those still running and available in your interaction. So this is what I'm actually doing with customers. So, what are we doing? We're trying to do a GitLab CI setup. We want to build the kernel and the device tree, maybe in an ramfs, ramdisk, right? We want to push that to a TFTP server. We want to launch Labgrid to boot that with the new kernel and the new DTP with U-boot TFTP. Run some really, really basic test cases. Make sure the kernel is okay. And then maybe we want to do something real, right? So my real test case right now is let's run kernel self-test or case self-test device tree subset, right? So what this whole thing looks like, so up at the top, you've got your CI system, whatever it is. In my case, it's GitLab in the cloud, right? But put anything there, doesn't matter. So then on the lower left, we've got a Raspberry Pi 5, which is the coordinator, but also in this case, it's the GitLab runner. And I've got the whole, this actual hardware is up here, so we can talk about it or after. So then I've got, next to that, I've got the Raspberry Pi 4, which is the exporter. So that's what's actually Puppet Master for the physical connections to the device under test. And that's running the PDU daemon also in my case. So that's what's controlling the power. Both of those are connected to the same Netgear switch, and they're actually both powered by PoE. Then we got the device under test, the BeaglePlay, and so that's just got an SD. It's connected to the SD wire for the SD card, so I can switch it between device under test and the server. Then I've got the PoE splitter, which is what's actually powering the board, and that's how I can cycle the power through the Netgear power PoE switch, and obviously the USB serial adapter. So if we look at what does the GitLab CI look like, I've got some common build setup stuff, right? But the actual build job, I'm just simply cross-compiling the kernel, and then I've got artifacts which are the kernel and the DTB, right? And this would also be the init ramfs if I was building that, right? So that's really all this particular job is doing. So this hasn't changed anything. This is what you're probably already doing in CI, okay? So then next, we have the Labgrid job. So this is where it's actually going to be running on the target. So I'm using tags with GitLab to force this to only run on that specific runner that is the coordinator, right? So now that runner becomes the bridge between the cloud and my lab, and then it talks to all of the exporters and all the devices that are present. So we've just got, we're depending on the build kernel, and you can see I'm copying the artifacts from GitLab Cloud to my TFTP server. And then I've got, the actual steps I do to run Labgrid. This stuff could be put into a kernel, into a container instead of specifying it in the GitLab CI. But to me, this makes it more obvious, like, wait, how do I do this if I want to run this on my command line or something? Like, this is how I currently do it. There's more elegant ways to do it, I think. And then it just runs a script, which basically calls the same command line that you've seen us already using. So why do we need all of this? So what was our goal, right? When we talk about automation here, the goal wasn't actually CI, right? It wasn't full hardware in the loop automation. It was just automating interaction with the hardware to stop having to do 1,000 times running the same damn commands over and over again. So do you really want to do this manually? No, because you're either going to forget it 6 months from now and then you have to relearn it, or you're just going to make mistakes. It's a really, really expressive way to handle your infrastructure, and all the aliases and things that we're using with bindings that aren't really required give you that mental picture of exactly what's going on, right? It's really easy to remember what you're doing. And then we want to do like KernelCI or Yocto automation, or build with ISR or build with BuildRoot or whatever it is, right? We want to add that extra step, but have hardware in the loop, closed loop stuff. So like Trevor's going to do, a Pocky generic ARM core image full command line build every night, and he's going to boot that every day and make sure it's okay. I'm going to do ICER or Yocto or BuildRoot or whatever, or I'm going to consume the latest images from BeagleBoard.org or whatever it is. So the next thing, or the last question, I think, is really like, how do we scale up? This was, Kevin's next big problem. So the scaling up, we're not talking scaling up more hardware. That's pretty pedantic, right? I can explain to you exactly how to do that. The scaling up's the metadata. How do we scale up? How do we easily have a whole bunch of new boards get added? And so it does depend on what you're trying to do, what you're trying to accomplish. We think that the docs actually cover this fairly well into like what the configs and everything need to look like. But when you add a new target, you're likely changing, what you have in your client file to make it more obvious that there's, this rack on this shelf is this device, and this device is already got the secure boot fuses burned and things like that, right? There's like things that start getting more complicated. One of the things you can do is you can have multiple targets in one scenario, right? So you're not necessarily running just one device. You might be running 3 devices together that are a system that work together, and that's part of your test structure. So the key, I think, is using these aliases and these bindings, but then to really scale, to really start solving 50 boards, 100 boards, 1,000 boards, we need to use templating. So we need to use Jinja 2. There's some pretty good examples of that, but that's what we've got to go with. So,
so what if we want to make different test flows available to the same target? So this is a different way to consider scaling. Maybe you've got more use cases for the same board. So I tested this out just as a simple example. So when I showed you the single developer Labgrid loop before, I had one boot command in the boot commands list that was going to TFTP boot, but I figured, okay, what if that doesn't come up? Do I want to have another state that will go back to the EMMC and try to boot that again just to make sure I haven't, done something awful with the hardware, or, my cat's knocked it off the shelf or something like that? So I added another state, which is just called EMMC, and I've added another status to the state machine called EMMC that does essentially the same thing. It just changes the boot command. So I can switch between these, again, using the Labgrid client command. It's just when I specify -s, instead of saying shell, I can say, or I guess in this case, the status is called TFTP, so I made a typo there. I didn't update it, but I can say -s EMMC or -s TFTP in this case and switch between the 2 boot modes. And in either case, assuming the kernel's good, it's going to come up.
So sometimes in your hardware rig, your automation rig, especially if this stuff is remote, you want to know, did I brick the board, right? Is the network down or whatever, right? So you always want some fallback. This is still fine, right? And for us, because we're just using stock BeagleBoard.org Debian images on the EMMC, we always know, right? Yes. So we had some challenges. I think for us as newbies, right, even though I was aware of Labgrid for a long time, the documentation initially was hard to follow. There's a lot of jargon and concepts that you just have to learn them, and there's a learning curve, right? But our feeling was that like we just need to contribute some more real world examples, right? So like Trevor's setup will turn that directly into documentation, right? My setup's starting to already be like different labs are going to do it different ways, right? So like how long do you want that chapter to be? It's probably not that great to like try to set it up that way. We love how expressive it is, but it's still kind of verbose, and there can be a lot of boilerplate copy-paste stuff. That's actually how I started off. Like every single board, I was just like copying all the files and modifying them, and just like, are you going to keep doing that for 1,000 boards? So we think there's some, tools that we could add to make that part easier. It can be expensive and difficult to get some of the hardware. So for instance, Pengatronics has some great devices that they sell, but they're not available in the US, right? For various reasons. So I could get them hand delivered at the hotel, but that's just me because I've got a personal relationship, right? So So my goal here was it had to all be public facing and it had to all be consumer off the shelf COTS, right? So that's everything I have up here is I bought it off of the web, right? I actually have customers that are trying to test production images. And so now you've got problems with secrets, right? So how are you going to store your secrets and your keys? You're going to want to use an HSM, TPM, and things like that. What if I have stuff that I need to do that needs sudo? But, I'm not going to run root, right? I'm never running root, but I'm going to use sudo. But now I need to run commands or wrap commands with sudo, and I don't want the sudo password to be showing up in my logs. And then I think really we want some proper output format. So if you look at my repo, I'm actually generating reports in HTML using this very simple pytest robot framework plugin. It's super easy, gives you really nice looking reports, done. So as we really start going to what some of you probably care about, right? It's like big labs, lots and lots of devices, your entire product line being tested. It's really context dependent exactly what that is, but we have this like resource exporter, definition dilemma. Like, how are you going to do all of this? So one way you can do it is one exporter and one setup per DUT. So that's my model. A lot of folks recommended that to me because you can take the exporter and the device under test offline and no impact to the rest of the system, right? But Trevor wants to maybe run 2 or 3 devices off of his one setup.
My shelf isn't very big.
Yeah, and he's got he's got the coordinator and the exporter and everything on one machine, and now he's going to run multiple devices, because that's what he's working on at the moment. We also found like toggling features. So I've got images where U-boot doesn't have a prompt, it does have a prompt, it needs a password, things like that. Or maybe I want to flash or not flash. Like Trevor's example of not using TFTP, but using just the eMMC that was already there type of thing. And then we kind of asked ourselves a question of like, how generic could these exporter and client configs and strategies be, right? So there's some commonality that we could like leverage, and then there's some stuff that really, really should just be its own thing, right? It's per board type of situation. So the cop-out answer really is like, it's all just in Python, right? We're all probably fairly good at Python, so we can just add another abstraction layer.
So talking about future work, there's 2 parts to this. The obvious one in bold at the top, incorporating Labgrid workflows and everything we do. Like, now that we have a good handle on how to get the basic setup going, again, my shelf's kind of small. I don't have that many boards in my board farm, but I want to get Labgrid deployed for every single one of them. Every time I do a new hardware setup, even if I'm only going to use it for, a day or 2, I want to, at least consider Labgrid and preferably set it up. There's some discussion about Yocto Project distro with GitLab CI and runners showing the test results with all this stuff.
And like you all know us both as Yocto people, right? So we're not really talking about Yocto much here because I knew I could do that. That wasn't the goal of this talk. The goal of this talk is to get you out there using Labgrid now, like immediately, right?
Yeah. Definitely want to use add more targets to our labs. Like I've got a Z board that I've been playing around with. I actually have a PR upstream right now on Labgrid to add support for an HS103, so a TP-Link Casa network power plug that I've been playing around with and controlling my Z board power with. As soon as there's an RVA 23 compliant RISC-V64 board and I spend oodles of money on it, it's going to be on my shelf hooked up with Labgrid too.
And I've got some NVIDIA stuff, but I'm going to start with an Orling Nano because that's accessible, cheaper. And I'm a big BeagleBoard.org person, so I'm going to do the BeagleBoard or BeagleV ahead as a RISC-V platform.
And the other thing too is you actually want to make use of the workflow here for some kernel development. So I mentioned this in the other talk if you were there at 9. We've actually got the hardware up here if you want to take a look at it. Micro has some waveform clickboards that plug into the BeaglePlay header in the middle of the board. There's one that I'm really keen on doing some development for that has a driver and staging right now, the waveform click, so I can do some waveform generation, and maybe down the road have this complete loop with my hardware where I'm using the waveform generator or my on-desk function generator to generate a signal, put it through a board, or alternatively control an oscilloscope too, and capture outputs from another board that might be generating something. Keep iterating until that those kernel drivers are ironclad. But the takeaway is that I want to make use of this to streamline the whole process, so I'm not spending time doing the whole manual control. As for part two, we mentioned before that sometimes it's kind of hard to build out all of the definitions. I spent some time playing around with Claude to create a prototype for what I call Labgrid Planner. Right now, it's mostly just a UI where you can go through and you can select a bunch of resources. It'll ask you which resources you want to define, and then which drivers, if any, you want to define, and then generate some files with just a template that you could probably fill out. I've also been thinking about this idea, grid top. So if you've ever worked with Kubernetes, you might have seen K9s, which is this really, really nice terminal user interface for like monitoring your entire cluster. So that's kind of the mental model I've got in my head right now for something that would kind of either extend Labgrid Coordinator or be run alongside it to just monitor and let a system administrator or like a lab administrator know what's the status of all these resources, where are they, who's using them, that sort of thing. There are some issues upstream we'd like to fix. There's one we've run into more than once with how paste mode's handled for some shells. So maybe we could just add some built-in checking for Labgrid. Obviously, there's integration considerations with KernelCI. Maybe some hardware tests we could use Labgrid for in the Yocto Auto Builder.
Or maybe QEMU.
Yep. More scalability and generic strategies. And then obviously, as we mentioned, build and document full examples using COTS hardware. So all of you in the room can go spend $500 and have a nice automated setup on your desk.
Yeah, so all my hardware is US-centric, right? But it should be more or less globally available.
So a special thanks to the Labgrid developers, Kevin Hillman and especially Jerome Brunet, who put together some of the early prototypes for some of the code you've seen and the resource and driver definitions and the strategy that I ended up modifying and using to show everyone here how to get started. And Jan Luba, who took the time to review our slides shortly before the talk.
And give us a lot of future work also, which was awesome. Also, we want to thank Kevin Hillman and Joshua Watt and John Mason, because they all sat through earlier dry runs of this talk.
So we'll take questions now, but just to finish up, there's not actually a booth, and the hardware can't be connected to the network, so we can show you how the hardware's set up, but there's not much of a demo. I do want to announce there is a discussion on the Labgrid GitHub about a bi-monthly discussion, technical discussion for Labgrid, so if you're interested, definitely check that out. And I mentioned early on in the slides, there's a huge appendix. So if you want to see some more details about, things, look at our abstract again for some reason. Look at some of our references. There's a whole bunch of stuff up here that we didn't cover.
There's just no way we could cover it all. So for me moving forward, obviously I want to add some new devices. I'm going to make a publicly facing, here's all the metadata. You can see all the test logs and everything for Yocto and other builds. ICER is already out there and a kernel build's already out there, but I'm going to expand that to other build systems. We've got discussions with Labgrid folks and with KernelCI folks to make sure that we get Labgrid as a first-class citizen for KernelCI and not just Lava, right? So that is going to happen, absolutely. If you're interested in that, please find us and we'll continue that discussion.
So thank you. Are there any questions?
Questions?
Thanks for the great talk, first of all. Do you have any experience that you gained regarding bootstrap testing, low-level flashing for Tegra or something like UUU support is in Labgrid, but I haven't seen any other platforms really.
So there's quite a bit of low-level support that's actually there. That was beyond the scope of what we wanted to present to you all today. When we started, we had grand dreams for what this was all going to be, and we decided to no, let's just get you out the door using Labgrid. So we just slimmed down to that. We both have interest in all that low-level stuff, so we want to be using Zephyr, microcontrollers, non-Linux builds and whatnot. Obviously, if you look at an ESP32 or something like that, now you're going to have a different mode of how you flash it and how you interact with it. So there's quite a bit of support there. I just want to tell you, Pengatronics has done a great job. There could be more, and so we also need to figure out what's missing. Let's document it. Let's write it. Let's add drivers.
Yeah, just to add to that too, there's a ton of features even with Labgrid client, right? Like we only showed the one to boot to shell, but there's an SSH one. There's a variety of different ones for just monitoring things, checking status, like doing a whole bunch of control. We just didn't have time to cover it all because there's a lot you can do.
And you can start having logic analyzers, SIGROC, and you can have an oscilloscope hooked up and start doing FFTs and there's lots and lots and lots of other capability here, but that was way out of scope of what we could cover today. Any other questions?
Oh, sorry.
Thank you. I'm wondering if some of you has this kind of use case of using stress test, so running the test sequentially, one after the other. Usually this is the use case. I'm wondering if some of you run more tests in parallel to stress the hardware and the software, using which kind of structure do you use?
So I think one of the problems that I see because you're starting to talk about where maybe one piece of hardware is now going to be utilized like for long periods of time in order to do enough loops of stress testing.
To validate both the hardware and the software.
Okay, so the
stress test, everything goes well, when is supercharged.
So maybe to validate both the hardware and the software. So we think that what we really didn't touch was like validating the hardware. Lots of stuff that you may have, right? And we're talking like full, pogo pins and all kinds of the rest of the stuff that your hardware folks are doing. Absolutely doable, right? So then you just have to think about planning out how you're going to hook up that hardware, the external lab infrastructure hardware to Labgrid. And then how are you going to interact with it? What are your test cases going to look like? What's your testing sequence? How are you going to run, what are you going to run when it's a PR? What are you going to run when it's a release build? What are you going to run when it's, agency testing, right? So I think that the scope of everything depends. That's why we said like the context depends. But we also think like the use of Labgrid, while we said like use Labgrid everywhere, we literally mean that, right? Like if you're just doing anything and you interact with a board, use Labgrid for that. The moment you're going to interact with something, use Labgrid. But if you're going to go to full-on agency testing and you've already done all of the rest of your testing with Labgrid, and now you can automate all your electromagnetic interference testing and all of that stuff with Labgrid, that's totally there too, right? So it's really like it's literally everything you do could start becoming integrated with Labgrid, and the more you do, the more you're going to see where you would use it. But I don't think any of that, what you're talking about, is out of scope at all. It's absolutely doable. We just don't know how yet.
I think we got time for one more quick one if there is.
Sorry. Yeah.
Maybe I missed the part, but my question is in the direction, how did you get the test image and the initial image or the version on the device? I imagine it was a network boot, and how do you do like an OTOUT update test then?
So
do you have some strategy there?
At least on my end, you're talking about what was on the MMC?
Yeah, for instance.
Yeah, that was a manual step on my part. I just took the BeagleBoard image for the BeaglePlay from their website and flashed it to the MMC, and then said that was my baseline. That's the U-boot version I'm going to use. That's the rootfs I'm going to use, and didn't worry about it from then on. After that, it was all TFTP.
Thanks.
But it should be possible to write enough to flash EMSC as well.
Yeah.
So in my case, I might be using like the SD card, right? So my output would have been a full complete image that would be flashed to the SD card, and that's what my ICER repo does, just as an example, because it was easy. But that could also have easily run the commands to flash that to the eMMC. So you could actually do your full factory install, right? Your actual real factory install could also easily be done with Labgrid. So if there's anything that you can do on the command line already, or that you can like describe well enough to me as to like how do you do it now, it just depends on like how much time and money do you want to invest in everything to make sure that it works and it's fully automated. But there is nothing that can't be automated, like literally nothing. It's just how much do you want to spend on it, and is it worth it, right? So.
Yeah, I mean, the BeaglePlay, when you boot it, right, it gives you 4 or 5 options on how you want to boot, like a debug mode or like from your SD card, eMMC, et cetera. So I don't think there's any reason why you couldn't match against that, and like you do with U-boot, and pick the option depending on how you actually want to set things up.
So like what I did for the BeaglePlay, from what was shipped to me, I just took a new installer image, used the Beagle Imager tool to put that installer image on an SD card, booted it, flashed it to the eMMC, and then after that, I'm not touching that image anymore. But I use Ansible to upgrade the Debian image, right? So there's other things I've got like Ansible. Lovely.